I just said that, right? We are not going to graph these. Our whole goal here is to try and see how we might be able to use exponential functions in the real world, all right? That's the whole point. So this is just an introduction and to get you used to the idea of plugging things into your calculator, what they basically look like. But now let's talk money. And we'll use exponential functions to answer some of these questions. All right, so the first thing is this. We are talking now about something called simple interest. Simple interest. So the idea here is let's think about how a bank works. Let's say that I'm the bank and you come to me and you want to borrow $100. All right? You want to borrow $100 from me. Let's make it 1,000, all right? So you want to borrow $1,000 from me. As a bank, I'm going to first make sure that you have some credit and that you have a history of paying debts back, right? And then if I feel like it's safe, I'm going to loan you the money, but not for free, right? You're going to have to pay me for that money. Now, I will allow you to pay it back to me over time, but it's going to cost you. So I have what the bank would call an interest rate. So depending on your credit and how trustworthy you are, that's based upon your credit score, then that will determine your interest rate. So if your credit score is really bad, you have really bad credit, I'm going to have a very high interest rate because I'm taking a risk by giving you money. If you're trustworthy, then I'm going to give you a lower interest rate. So let's just say your credit isn't that great, okay? And I charge you 20%. And let's say I tell you you have to pay it back in a year, right? So I'm just going to loan you the $1,000 and you are going to pay me back 20% at the end of the year. So how much will you owe at the end of the year? How much will you have to pay back? You'll have to do 1,000 that you borrowed plus 20% of it, right? So you would owe $1,000 plus 20% as a decimal times the 1,000. Agreed? So this is going to be $1,200. So yes, you will have gone and bought that gaming station you wanted and that big screen TV, but you're going to pay an extra $200 for that because you borrowed the money, right? That's the way interest works. So the bank sits here, right? And you come over here and you want to borrow money, right? So you want to take money out. You want to take $1,000 out, but you promise to pay back $1,200, right? So the bank is going to make $200 off of you. Agreed? Now, where did the bank get their money?
From other people.
From other people that have the money, okay? So now you have people over here that say, you know what? All my paychecks, I'm going to put them into the bank, right? So maybe they put in $1,000 here, let's just say, okay? The bank says, you know what? Thank you for your money. I'm going to hold on to it, okay? It'll be here if you need it, all right? If you put it in a savings account, you can only withdraw from that account a certain number of times per month or something. But they say, your money's here, don't worry about it. They said, because you're letting us borrow your money, we are going to give you some money for your money. So there's an interest rate on this side too, but it ain't 20%, okay? It's like less than 1%, depending on what you put it into. But if you just drop it into a checking account or a savings account, you're basically, they're paying you, but not much. So maybe you'll make like, I don't know, $2 off of that or something. Let's just say $10, all right? Let's say somehow over your $1,000 that you're letting them borrow, you're gonna make $10 off of it. So the bank takes your $1,000, loans it to this guy, They pay back 200, they give you 10, and they make 190. That's the way a bank works, okay? When you get a credit card, right, you're borrowing money from a bank, and your interest rate is usually about this high. Credit cards have crazy interest rates. I have a really good credit score, really, really good. And the best interest rate that I can get on a credit card is 9%. 9. Okay, so if you're a college student or something like that and you're just trying to make it through, you're going to be paying 18%, 20%, it just depends, right? So that's the way a bank works. Now, the bank has formulas that they use to determine how much you're going to owe after a certain amount of time, because unfortunately the bank does not use this simple formula. They do not take your money and let you borrow it for a year and charge you 20% and it comes out to $1,200. What they do is they calculate your interest more often. So what they do is they say, instead of just calculating the interest one time on this $1,000, we're going to calculate it every month. But instead of doing 20%, they do a 1/12 of 20%. And instead of doing it on $1,000, they do it on a 1/12 of that. So it gets complicated because people do monthly payments, so they have to do things that are more frequent, if that makes sense. So what I'm going to give you right now is a formula that allows you to calculate how much you are going to have to pay back after a certain amount of time, okay? At a certain interest rate. And there are going to be two formulas. So let me write the formulas down first. The first formula goes like this. A equals P, parentheses, 1 plus R divided by N, all of that raised to the N times T. Does that look somewhat nasty? The next formula, A equals P times E. Yeah, E. Okay, E. That's the E we were just talking about. E raised to the RT. Which of those two formulas looks less complicated? The second one. And this is the one that most banks use right here. All right? But these are the two, and there's differences between the two. We need to talk about what all these letters mean. Let's go and do that. All right? So what the letters are in these formulas. First of all, P. P is called the principal, and not like the principal that you get sent to the principal's office. This is the principal. This is the starting amount. Okay, so if you go borrow money, right, that's the amount that you borrow. If you are putting money into the bank, this is the amount that you put into the bank at the beginning, okay? So remember, there's two people at the banks, the people taking out, the people putting in. This is the amount that that person either puts in or takes out, depending on which side you're on. Understand? Okay, so P is the starting amount. Okay, R is the interest rate. And there's something very important about this interest rate. You must convert it to a decimal in the formula. Do you see the R in the formulas? You see the R? It occurs in both formulas, right? The P is in both formulas, the R is in both. When you plug that R in, if your interest rate is 20%, you do not put 20 here and 20 here. Understand? You have to put 0.2. All right, so R is your interest rate. What else is in both formulas? T. So T, what do you think T is? Time. And time here is always measured in years. Okay, time is measured in years. And A is in both formulas, right? So A is the amount at the end of time. And I don't mean the end of time for all mankind. I mean at the end of this time right here that you're talking about here. That's the amount that you'll wind up owing at the end, or the amount that'll be in the account at the end. So if you're putting money into the bank and you're not going to touch it, you're just going to let it sit there and let the bank pay you for your money, the A will tell you how much at the end you will have. On the other hand, if you borrow money from the bank, right, this will tell you how much money you're going to owe at the end after the interest has been accounted for. So there's one more thing that we have not accounted for here, and that is the little n. Do y'all see that n? And that n only appears in this formula. And this n is the number of times the interest is what we say, or what we call compounded per year. And let me give you some examples of the n's that you will see. All right, so I'm kind of out of room, so I'm just going to stick it right here. For n's, if n is 1, that means you're compounding yearly. That means they only compound your interest one time throughout the year. If n is 4, that means they're compounding it quarterly. So every quarter of the year, they calculate the interest. So n is 4 in that case. What about if n is 12? Monthly. And you can go further than that. You could have like n being 365, which would be daily. Oh, that's not the way you spell daily. And I won't give you anything other than those possibilities in here. Now, I don't want you to misinterpret what this n is, all right? Because a person would look at this and they'd be like, look, would you rather have the bank compound your interest one time in the year, or would you rather have them compound it every single day? Most people will say, go with the yearly, right? Just one time. But it turns out that this, remember I said they're compounding it every day, but they're not doing the whole interest rate on the whole amount of money. They're cutting everything by 365. So it turns out that the difference between this and this is usually just pennies. All right, so there's not a huge difference. So do you see that this formula right here doesn't have n? Right? This one does. So this formula is a very special case of this formula when we let n become infinite. In other words, they're compounding your interest at every instant of every moment of every day of every moment of time, okay? It's like let this n go to infinity and that n go to infinity, and what happens is you get this formula. So there's a special word for this one. For this one, we only use this formula when they tell us we're compounding continuously. Okay, so when you see that continuously, in the word problem, when they're presented with the problem, they say, hey, you've got this interest and it's compounded continuously, it tells you to go to that formula right there. If they tell you the interest is compounded monthly, you're going to use that formula. All right? All right, let's do an example. You all ready? By the way, I call this the shampoo formula because there's a shampoo called Pert. I'm not the only one that has heard of that. Come on, I know some of y'all use Pert, right?
It's in a green bottle.
It's in a green bottle, yes. Are you ready to do this? All right. So let's look at, first of all, a bad scenario. Somebody who owes money, okay? So let's say that you have my best friend has never been good at his personal finances. He's always had trouble. I think he declared bankruptcy in his mid-20s. He's been in debt several times. He can't get it together. He recently bought a vehicle, a used vehicle, at basically 18 or 19% interest rate, which is just crazy to buy a vehicle. That's like buying a vehicle with a credit card. Okay, so let's take his scenario here. You buy, I don't know how much he paid for it, but I'm just going to make it up. You buy a $25,000 vehicle. A vehicle, what am I, oh, you right? Let's not make it 18, let's just go like 15% interest. What we're going to do here is we're going to assume that he's not going to make a payment for a while, just to see how much would this debt grow if he didn't make any payments. Now, he has to make payments, but we're just going to take a look at how fast this debt will grow. Right, so you buy a car, you buy a $25,000 vehicle at 15% interest. Okay, so here's the first question, part A. How much is the debt after 2 years if the interest is compounded monthly? How much is the debt after 2 years if compounded monthly? I didn't put if interest, but y'all understand what I mean here? Okay? That's part A. Part B is the same question. Okay? Debt after 2 years compounded continuously. All right, so let's do part A. We'll do part A and B, and then we'll take a break. I know it's already past our break time, but... Or do y'all want to take a break now and then come back? Just finish it? Okay, so part A. Which formula are we using? First one. So I'm going to write the formula down. A equals P, parentheses, 1 plus R over N raised to the N times T. All right, let's talk about what we know here. Do we know P? $25,000. Do we know the interest rate? 15%. We've got to convert that to a decimal. Do we know N? 12, right? Monthly is 12. And T is 2 years, okay? All right, so can I like plug everything in, or do you want me to write down P is this, N is this? Just plug in? Okay, so the amount that we will owe, our debt, will be 25,000, parenthesis, 1 plus 0.15 over N, which is 12, all of that raised to the 12 times 2. P 1 plus N, R over N raised to the N times T. All right, so it's time to get our calculators out and let's compute some of this stuff. I'm going to do this first. I'm going to do that on my calculator because I'm doing what's in parentheses first. Do that, and I'm going to add 1. So make sure on your calculator you can get the same thing here. 0.15 divided by 12, and then add 1. And when you do this, I want you to use as many decimals as your calculator gives you when you write it down here. 1.0125. And then I'm going to raise that to what power? 12 times 2, right? Which is 24. Now, do I take this and raise it to the 24, or do I multiply these together first? What comes first, multiplication or exponents? Exponents first. So make sure you do this to this power now. So take that, raise it to the 24th. I'm going to write that down, 25,000. And now when I multiplied that, or raised it to the power, that's what I got in there. And notice I wrote down all the decimals. And now I hit times 25,000. And after 2 years, if he were not to touch that debt and just let that thing grow, he would now owe $33,600. $683. So let's do something. Let's take that, let's subtract 25,000. How much in interest did it grow by there? $8,683. So in 2 years, he now owes the bank $8,000 more. So for those of you who have credit cards, let's think about this. What if this were a credit card? All right, same story. You know, on a credit card bill, it'll say like, if you just make the minimum payments. Have y'all ever seen that before? If you just make the minimum payments, then you'll pay this off in like 8 years and you will have paid this many $1,000s in interest. But if you make this payment, you'll pay it off in 3 years and you'll only pay this much in interest. The idea is this. That amount is going to grow, okay? It's going to grow off the interest rate unless you're paying enough each month to counter this much growth. So if it grows by $8,600 in 2 years, then that means every year it's growing by about $4,300. Okay? And if we divide that by 12 months, that means you would have to make payments of like $350 just to counter the interest every month. Just to counter the interest. Just to keep it from growing. That doesn't make it go away. It just balances off what you owe for borrowing the money. I hope that makes sense. Does it make any sense? Yeah? Okay. Now, what's the answer for part B? For part B, we have a different formula, right? It's actually an easier formula, but it requires that E key on your calculator. So let's see. For part B, we're going to have P e to the RT. P is 25,000. E to the R, which is 0.15, and T is 2. So notice on this, there's no N, right? There's no N in this formula. So when I do this, order of operations, I'm going to figure out what this is first. So what is 0.15 times 2? 0.3. And now what I want you to do is what you did before. Do e to the 0.3. So you'll need that special key on your calculator. And then multiply that times 25,000. Any questions on what I did there? What was the answer for part A? 33,000. 683. 77 cents. So yeah, there is a difference, right? There is a difference between these two formulas. If they compound the interest continuously, you wind up paying a little more, don't you? Right? But it's not drastic. It's not like this is 40,000 versus, 33,000. But it also works on the other end. If you're putting money in the bank, they use the same formula. So it helps you if you're putting money in. It hurts you if you're taking money out. Okay, let's take a break. It's 12:25. Let's come back. It's 12:26. We'll go 12:41. I'm going to start class at 12:41. Restart.